People say that it is both dead and alive. But it is not believable, no? So we are not understanding what do you mean by both dead and alive. So that is the concept of superposition. And once if you open it, that is known as actually the concept of measurement. So that superposition will be transferred to the classical outcome. So as long as the box is closed, we'll say that the outcome is in superposition state. But once if you open it, the answer has to be either one, either dead or alive. Are you getting my point? So that is the thing. But once again, I'm telling, if you go through n number of websites, you will be majority of the time you will be seeing only this example. So if you read it for 2 times or even 20 times, you will have that same confusion in your mind. So what do you mean by dead and alive? How we can say that it is dead and alive? Yes, we need to say it. That is the concept of superposition, because we have not opened the box. That is very important point that you need to remember. Once if we open the box, surely we should say it is dead or alive. As long as the box is closed, we call it as it is in the superposition. That means it is both dead and alive state. So that is experiment, and this is another experiment, that 0 and 1. Or people also use one more example: toss the coin. Okay, so as long as it is in the air, so people say that it is both head and tail. But once if it is coming to your hand, so that means you are stopping it. So that means you are converting that superposition into the classical output, that is considered as measurement. The word measurement we will use in our quantum environment. With that, we will say that it comes to the actual output. But once it is stopped, then we should not use the word and. We should say either head or tails. Okay. So like that, there are different examples that you can come across this. And there is another thing that is known as entanglement. So that means once if you are changing in one location, the one which is connected to this also will be changed. And for this, generally I request my students to remember that movie, Hello Brother movie, Nagarjuna movie. Have you seen? So what is that? So once if there is a change that is happening here, because of this, the change is also reflected in the other boy who is at some other location. So here the concept of entanglement is exactly that. So for the first one, I'm requesting you to remember that God example or something. Whereas for this one, you remember that movie, Hello Brother movie. So with those two topics, I think at least we can manage initially. Even if you have confusion, you read a number of articles. Everybody is talking about only this, kind of similar kind of this. Okay. And the other one is considered as quantum interference. Sorry, actually, I will skip this a bit quickly, because these are the words just you need to remember that they are part of quantum computing. But even if you don't know anything about it, doesn't matter as of now. Okay. And yeah, quantum interference means, so when you take one outcome and another outcome, so one is having impact on another one. At least by seeing this, you can understand. So when you add these two, which is known as constructive interference, the signal is increased. These two are known as destructive. Okay, that is about from the quantum physics. And wave particle duality, tunneling, and decoherence, and mainly about the last things are probabilistic nature. So this is very important point you need to remember, because in our computers, whatever that outcome that you consider, no, that is known as deterministic. Whereas in quantum environment, whatever the outcome that you get, that is considered as probabilistic. For this, just you can go through the internet and just type what is the difference between deterministic and probabilistic. So deterministic system, so it need not be about quantum or anything. When you consider deterministic, I think how many of you are from computer science? Then you raise your hand. Okay, good. So all of you have studied deterministic, no, somewhere in some subject. What is that course name, subject name? Deterministic? In which subject you have studied deterministic followed by some word? What is that? Yeah, deterministic and non-deterministic. Yeah, which subject? Flat. So what is the difference between deterministic and non-deterministic? Same meaning here also. Deterministic means what? On a particular input, clearly you can tell what is going to be the outcome that you are going to get. So what about non-deterministic? on the same input A, so there is a chance of getting two outputs or two or more than that. That is non-deterministic. So this probabilistic is in between deterministic and non-deterministic. That's all. And see, many of the topics, better you see the meaning from the dictionary, then you start exploring that particular topic. Directly don't jump into textbook and start reading the whole technology. So it is very difficult to remember or understand the technology. If you know the meaning, I give guarantee that 50% of the technology that you are about to study will be having 100% clarity in your mind. If you know the meaning of deterministic, then non-deterministic, and in between that probabilistic, I think you will be, if you go through the internet these days, you will get n number of examples. So better you understand the normal examples first, then you can see how that can be considered as a probabilistic in quantum environment. Okay. Okay. Right. As I already told you that, so obviously we know that the supercomputer is or the fastest, but now the quantum computers are even faster than that. Now, when I say faster, what is the thing that you need to remember throughout your life? At least if you want to be in quantum.
Sir is on unmute the resource person, sir. Not audible.
Yeah, not audible.
नहीं इसमें वो चल रही ना। हाँ समझ गया मैं, वो चल रही तो नया फोन है यार। नया कहाँ उठ रहा था? तो कौन सा मॉडल है? 2015 मेरा मेरा है भाई।
Even if you use the after that also there is no guarantee.
कोई सही था तेरे?
You may be feeling what is there, but when you take a large number, is everything they tell 2048 big number.
क्या नहीं नहीं मैं
Hello, sir, you are not audible.
अभी हाँ जाने की बात होगी तो मुझे बता दो। खाना वाना खा कर निकल जाइए, वरना खड़ा रहना तो खड़ा रहना, बैठना तो बैठने।
Hello.
Fine. Okay.
Yeah, hello. Yeah, is it audible now?
Now it's
Sir.
audible, sir.
Hello.
Now it's audible, sir.
Yeah, okay, right.
Yes sir, audible sir.
Can you go to our PPT?
Yes sir, please.
Sir, PPT.
Yeah, here I have given when you consider the 2048 bit number, so it is going to be very almost impossible to do in your the best classical computer, but in quantum computer we can do it by using some of the algorithms. And of course, so see here, factorized supercomputer, practical infeasible, and personal computer is almost impossible, and it is still impractical years or centuries. But whereas in the quantum computer, it will take seconds to hours to complete it. Because of that parallelism, because of that superposition concept, because once if you are changing it here, so the change is going to be reflected in all the qubit wherever it is available, it is going to be immediately, it is going to have its impact on that. So because of that, we can say that we reach that that kind of speed. Okay. Okay, this is all not required. And applications. Okay, then for all the people who contributed in this, just I'm giving some names here. And Deutsch algorithm, and actually generally when you want to learn about this quantum computing, of course surely I'll be showing you something related to this Deutsch algorithm in the afternoon session, and he has contributed a lot. And this is the first algorithm that generally we study, which is used for checking whether a given function is constant or balanced. Okay. And Shor's algorithm, this is also one algorithm which is used for factorization, because that's the one which we have discussed so far. So he has given that quantum flavor of that algorithm to find out the factors. Of course, in this algorithm, when you are exploring, you need to know about a quantum Fourier transformation. Before understanding quantum Fourier transformation, if you are comfortable with the Fourier transformation, then it is easy. Have you heard about Fourier transformations? Then it is easy for you to understand. At least you can attempt to say that to look into the quantum Fourier transformation, and that is the concept that is used in Shor's algorithm to find the factors. And this is another one is the Grover. He is also contributed, and there is one algorithm known as Grover's algorithm. So this is his algorithm in quantum environment is used for searching. And whenever I am using the word searching, so immediately you realize that it is one of the searching algorithm. So what are the searching algorithms that you know so far? Linear search and binary search. Then what is the intention of those two algorithms? What is the input and output in either of those two algorithms? So input is one number given, and our task is to check whether that number is available there or not. If it is available, we'll say that it is available in so and so location. Even though I'm telling it as Grover's algorithm, so that algorithm main intention is to search a given number or quantity, whatever it may be. Output has to be exactly same. Yes, it is available or not available. But as he is using the quantum flavor of it, we'll say that it is going to be very, very faster when compared to your either even with your binary search. Okay. And these are the other people who contributed, and this is the general standard textbook we use to study this, or whenever we are dealing with teaching in the classroom, we use that textbook. And who will be next? Which name I want to include? I have to include here. Yeah, madam, your name shall I write there? Okay, please, you think like that. So at least if not now, maybe after 10 years, I'm expecting some of your name to be written here. No, you have to have such positiveness. Then at least see, we can't be Einstein, and we are not the people who really invented everything. But at least we are leading our life comfortably because we started learning quantum computer. And the big advantage now here with the quantum computer is that everybody is talking about quantum computer. Even in our Andhra Pradesh, you know that there is a lot of things going on quantum computer. As many of the people here, they are new to this, so we need to take the advantage of that. If you, because when you something is not known to everyone, if you know little bit in that, you will be considered as the very experienced person in that. Whether you believe it or not, around 20-25 years back, so you can ask your brothers, sisters, or even elders to around 20-25 years back, when mainframes in quantum computer science, so there is some concept known as mainframes. So during those days, so that many of the people, they don't know anything about mainframes, but in US they need a lot of the people who knows about mainframes. So I heard that during those days, who learned how to switch on and switch off that mainframe computer, they went to US and they got a job, and after that they learned it, and they succeed and they settled, and they earned a lot of money, and now they might have bought many things in Vizag and Hyderabad or in many places, because at that moment of time, as US people need mainframe professionals, as there are not many people available, those who learned very fundamentals in mainframes, they got an opportunity to go to US and settle there. So I'm not telling that same situation is like that, but at least as of now, if not to that situation, at least in Andhra Pradesh, we can say that people are like, no, government is ready to spend good amount of money on quantum computer, and they are looking into the people who can do something in quantum computer. As we are in the beginning of that quantum era in our region, so better take the advantage of this time period and learn basics. And even see, even I am also not know anything about quantum computer in last like before 1 year. So because as I started exploring it, and last summer I have taken around 20 internship students, because of that I learned little bit, and in last semester I have taken this course in our quantum in our college. So because of that, now I came here and at least delivering something on quantum computer. So with this knowledge, whatever I gained in the 1 year, I am going to cover in this 1-2 hours. Then you take the advantage, and you, after that, whichever the domain that you like in this, you need to take it and you explore, and you can get more benefits out of it, because you need to take the advantage of the time. After 3-4 years, if you say that you know the fundamentals of quantum computer, then nobody recognizes it. Okay. Then, so in our main work in quantum environment, generally I work with quantum image processing. So this is the basic diagram that we need to follow whenever we are working with quantum image processing. So I think in the image processing, little bit about image processing I'll talk in the afternoon, but this is the whole block diagram. So the one which we are doing now so far is that blue line. That means by using your existing computer, that is classical computer. Even your supercomputer is also considered as classical computer only, because that computers are made with the present technology. But the quantum computer is entirely different. It is made with quantum mechanics. The principle in making that hardware itself is entirely different. So because of that, we are getting speed. But once again, I'm telling no, 2 plus 3 has to be 5 in any of the device, even if you work with quantum computer. And not only that, even any of the language that you use to work with quantum computer or classical computer. For example, you assume that you have written a program in C language to add 2 numbers, and after that you learn Java, then Python, and you assume that you have written a program to add 2 numbers. Then which language will give the correct answer? 2 plus 3 is 5. You have written a program to add 2 numbers in C language, C++, Java, Python, and any other language, which MATLAB, let us assume. Out of all these 5 languages, the program written in which language will give the correct answer? 2 plus 3 is 5. All 5. Then why you need to learn so many languages? Okay, each language is having its own advantage. Because of that, you are learning, but answer should not be changed. In the same way, whatever the computer that you consider, the 2 plus 3 has to be 5 only. Even if you consider quantum computer, of course, people say that in quantum computer there is a chance of getting some noise. That is different part. If you say that in quantum computer there is noise, you consider 2 plus 3 as 5.5. Will you accept it? No. Okay, whatever you remove the noise, and we must say 2 plus 3 has to be 5. Okay. In the same way, so as this is about that image processing, so this is considered as image processing by using classical computer, and the other way which is shown here, it is doing some image processing by using quantum computer. But answer has to be same. That is what you need to understand. Whether you do by using classical computer or by using your quantum computing environment or quantum computer, answer must be same. You should not say that I'm getting different answer in different computers, then that is of no use to anyone in the world. Okay. Then when you want to work with this quantum computer, the fundamental unit in quantum computer is qubit. Whereas in our classical computer, it is bit. Do you know how the word bit is made? binary digit. Then how the word qubit is made? Quantum binary digit. Are you getting my point? So by using those bits in our classical computer, they build circuits. Okay, so before circuit, sorry, they implement gates. So what are the different gates that you know? AND gate, OR gate, NOT gate, XOR, XNOR, NAND, NOR, all the gates. Exactly in the same way, here we'll be having Q gates. See, bit, quantum bit, then gate, quantum gate. Then by using gates, what generally people do in the normal existing electronics, they make circuits. Then what could be the equivalent word in quantum environment? Quantum circuit. That's all. Once if you know these three things, the whole quantum computing is about making the quantum circuits. Okay, here you can skip. Okay, yeah, I think just I'm skipping all that. Anyhow, we'll be seeing in the afternoon session if time permits. Because just to remember that, because here we have only talk about the whole flavor of quantum computing. That's why I'm telling it. So bit and this one, and here these are all the some of the possible gates. So here when I say X gate, actually here from here we start explaining to the students about all the gates, but this is equivalent to your NOT gate in our like the present existing electronic devices. So what is the functionality of NOT gate? If I give 0 as the input, it will make 1. If I give 1, it is 0. So the equivalent of that in quantum environment is poly X gate. Otherwise, you know, some people write it as NOT gate also. And this is a poly is name of the scientist who has given that gate in quantum environment. That's why we call it as poly X gate, poly Y, poly Z gate, like that. Then, and the main gate that you need to understand here is Hadamard gate. So that is the gate which is used to obtain the superposition. So what is the concept of superposition? Existing the same thing at multiple locations at the same time. Okay, we'll see how that Hadamard gate can be used. Only with these two gates, I'll explain some image processing part. Then easily you can understand that. And whatever the example that I'm going to show you in the afternoon, even if you don't know anything about quantum computer, I hope you can understand that. Okay. Then finally, I told no. So this is considered as digital circuit, and this is known as your quantum circuit. So once if you say that you are writing a program in quantum environment, the outcome of that program is nothing but making the circuit. So once the circuit is made, here we use something considered as measurement. So from this measurement, you will be seeing the outputs. And once I'm telling no, even in that cat example, when we will say that we are measuring it, when you are opening the box. So whenever you are saying that you are using measurement, the concept of measurement or measurement gate, will say that we are converting that superposition state into classical state. Once again, I'm telling superposition means it is going to exist in multiple locations at the same time. But once if you say you are converting into classical, it has to be given as either 0 or 1. The final outcome must be pronounced there. So this is the measurement. Just to get the feeling, I'm showing what is quantum circuit. And I see all the algorithms and whatever the work that you do in quantum environment, our target is to make the circuit. Then how to make the circuit? By using gates. How the gates will operate? By using like bits, quantum bits. So here each and every horizontal line is considered as one quantum bit, and each and every symbol that is used here, or they are known as quantum gates, and all together this is known as quantum circuit. Okay, so we'll be working at least in our if you consider as a syllabus, we generally discuss about different algorithms. The Deutsch algorithm. The outcome of Deutsch algorithm is nothing but one circuit, and there is one algorithm, Deutsch-Josa algorithm, that also the outcome is one circuit. So in the circuit, you are going to tell. Finally, we are going to measure. By seeing it, you will be seeing the final outcome. And here, as I am telling, everything is one algorithm. Even Shor's algorithm, Grover's algorithm. So can you tell me what is the final output of Grover's algorithm? Whether you need not worry whether you understand that algorithm or not. But what is that? That is one algorithm that is proposed by some person, and because of that we have given the name. You forget about the name, then you think only about the algorithm. And what for that algorithm we discussed so far? Searching. Then what should be the output? One location, yeah, found or not found. If it is found, we need to say where it is there. So in the when after seeing the circuit, when you go to this concept of, when you see the measurement part, there you will be seeing the number where it is found. Otherwise, somewhere if it is not, the number is not found, we'll say that element is not found. I'm telling you to understand. Don't think that you need to understand everything. Just I'm telling you, it is an algorithm. Okay. Then, okay. Now to work with this or to understand, so far just we have given the broad view of the quantum computer. But really, if you are really interested in learning this quantum computer, first of all, you must start working with the complex numbers. This is your school maths only. Really telling, no. So I taught the subject in the last semester in my college. So without going through this internet or without going through these two topics, complex numbers and vectors, please you note down that. Those who are really interested, you spend at least 2 hours on these two topics. You try to recollect what you have studied in your school days. Then you start really looking into this quantum computer. Don't, if you start directly, if you directly jump into the, what is that, quantum computing, like, theory, you won't understand anything without understanding this. And really I'm telling you, this is not very big maths. It is very, very, very simple mathematics. So what is complex number? What is the general form of complex number? A plus IB. That's all. I think all of you know it now. Then what are the different representations of that complex number? So the A plus IB representation is known as rectangular representation, and there is something known as polar representation of that A plus IB. So can you tell what is the polar representation? Cos theta plus I sin theta. And there is something known as exponential representation of that, e to the power of I theta. So just you see all these three and the relationship among those three, and so not relationship, how to convert from one form to another form. Now, seriously I'm telling. So even when before 1.5 years back, actually I thought of looking into this. So I haven't revised that. When I started looking into that, they are telling something about all this, then I could not follow anything. Then I demotivated and I kept it aside for 3-4 months. Then after that, one of my friends just told that, okay, you need to just see it. After that, you start exploring that. I spent 2 hours on each of these topics. Then when I started looking into that, almost the whole semester I enjoyed a lot, because the whole topic, whatever that theoretically they tell, it is all about complex numbers and vectors, and how to convert from one form to another form, you see. And even I'll share the slides also, which is made by one of my friend. They're excellent. And in addition to that, you go through in your style, you can learn it. And without learning it, don't jump into learning that. Don't expect that you can understand. Then other one is about the vectors. And even in vectors also, you need not worry about the whole vectors concept. Okay, vector addition, multiplication, subtraction, and division. And when you say that multiplication of two vectors, there are 3 categories. Do you know what are the 3 different styles of vector multiplication? Dot product, cross product, and tensor product. Okay, just you explore those 3. And this is our school maths only, but to try to recollect. Otherwise, just you can go through the internet, you will find a number of what is the resources. And for this whole concept, the basis your Pythagoras theorem. Because even I also have forgotten all the maths which we studied long back. That even vectors also, there is a lot of confusion initially to me. But the basis for this is this right angle triangle. But once if you start going through this, and you can really understand what is that vector and vector addition, okay, and vector different operations on the vector. So everything you can go through that internet. I think I thought of yeah, this is the website I followed. Because when you start from here, then you need not worry about even the vectors, because I think many one of us, almost every one of us, I feel like very much comfortable with that Pythagoras theorem. What is that theorem? Now almost 6th class, 7th class we have studied. Diagonal square equal to a square plus b square. Okay, you know that, no? And we know that this is right angle and theta. And you know what is the formula for this theta here? Opposite by hypotenuse or adjacent by hypotenuse. So everything is revised in this particular video. You start from there. Even it takes 1 hour, 2 hours extra, but it is worth of it. After that, there is nothing to understand about the vector. Then once if you have given it, then this is considered as a vector. Then when this is theta, and this, if you draw one line from here to here, then obviously it becomes one right angle triangle. Then from there you can play once again. Okay. Yeah, see, he has drawn one line here, one line. You know how to measure this. That is opposite into, what is that? Sin theta, you know. That is opposite by hypotenuse or adjacent by hypotenuse. All the story behind only this particular diagram, your right angle triangle. And after that, that vectors comes into picture, and vector multiplication. And see, this is the concept how he has explained that vector addition. As you know this concept, and adding that is vector addition. But so that's why I'm telling you, don't by heart the formula. Maybe school days we did that, majority of us. But now at least to get the concept, as there are n number of resources available in the YouTube or any other thing. Previously, when you want to learn about it, you need to approach someone who is expert in that. But you now, if you can go through the internet, you will find a number of videos. Whichever you feel comfortable, you follow that, and make sure that you are not by hearting the things now. Okay. And this is vector multiplication, subtraction. Then when I say multiplication now, so there are 3 categories. So dot product, the cross product, and tensor product. And everything is explained here. Okay. This is about tensor product. Now, when after learning all this, when you start looking into the quantum environment, people talk about 2 words, ket and bra. Okay. And that is also known as Dirac notation, because the person, the Dirac, he has given this notation, but ultimately, please you remember that ket and bra are nothing but vectors. That's all. Once if you know it, then you can enjoy from then onwards. Then as you already studied about vector, now I am telling that ket is nothing but one column vector. And I am telling that bra is nothing but one row vector. But they are vectors. And what will be there in column vector or row vector? You will be having some numbers. So, but here you will be having the possibility having complex numbers as part of the vector. So that's why we insist you to go through the complex numbers and vectors concept. Okay, now see here, this is nothing but ket representation. So this is represented with one symbol that is known as this vertical bar and one greater than symbol. So this is the symbol used to represent this ket. But ultimately in your mind, what you need to think, ket is nothing but a vector. What kind of vector? Column vector. What can be the components in that? It can be normal, your normal digit numbers, or it can have your complex numbers. So once if you have complex numbers, then obviously, then what are the possible operations that we can do on these vectors is all about your quantum computing. So even though previously I have shown you one circuit, so circuit is made with some gates. So in each and every part of that entire diagram, you will be seeing about only these ket and bra notations. Ultimately, they are nothing but vectors. They are where the vector can contain complex numbers or your normal decimal numbers. So there is a possibility. So obviously, when you know that it is having some complex numbers, you need to work with multiplication of the complex number, addition of complex numbers, or subtraction of the complex numbers. If you know, then you will enjoy this whole subject. Okay. So this is, yeah, this is bra. So once again, I'm telling no. Now you see what is the difference between previous representation and this representation. This is, I'm telling no, I'm using these 2 symbols now. So what were the symbols that I have used to represent this cat? Vertical bar, then the symbol psi, then the greater than symbol. So whereas if they want to write bra, they use less than symbol, then that psi and this vertical bar. But the components of that are nothing but your complex numbers or decimal numbers. But this is considered as row vector. The previous one is column vector. Okay. Yeah. Now see here. So this is the bra notation. Yeah. Get the bra corresponding to cat. Yeah. If somebody is giving the cat representation, if I ask to get the bra equivalent of that, that is nothing but complex conjugate of that. What is complex conjugate? Transpose of that. And if there is I in that complex number, you need to make that minus I. If minus I is there, plus I. So you see that whenever I am using the word complex conjugate, just you type in the Google, you will be getting a, n number of examples. You take simple example and you can do that. Now, so what are the possible operations that you can do on this bra and cat? So there is considered as bra and cat. When you work with bra and cat multiplication, you will be using the dot product, and the outcome is one scalar. And whereas when you use between cat and bra, we consider it as cross product. When you use between cat and bra, we consider it as tensor product. Actually, by mistake, I have given it. Sorry, I modified this. I'll give the updated slides. Okay, the whole circuit is the third point, the cat and cat operation. So once again, I'm telling, don't consider cat as an entirely new word. So in your mind, at least for the time being, you consider what is cat now? It is a vector. You remember only that point as of now. So whenever I say multiply one vector with one column with another column vector, that is nothing but your cat and cat operation, which is considered as tensor product of two vectors in quantum mirror ornament. Okay, so these are the different examples I have given, and these are considered as basis vectors. And another thing that you need to know about the identity matrix and unitary matrix. Do you have any idea about the concept, the word unitary matrix? It is a matrix, first of all, with some additional property. What is that additional property? Here I have given now, unitary matrix. Yeah, U and what is how do you pronounce this? Dagger. If you multiply those two, you will be getting identity. How to get that U dagger? That is nothing but complex conjugate of U. See, and one more thing, one more point I want to tell you is that ultimately, when you simplify the given or the quantum circuit that we made for the given algorithm, the whole circuit can be represented in one unitary matrix. And once again, I'm telling, don't think this as a very big maths. Really, I'm telling you, if you spend 4 or 5 hours before start exploring this quantum computing subject, you will enjoy the whole subject, provided if you come across all these words whichever I have given here. Because after this, the whole subject is made with only these words. One is complex number, vector, then unitary matrix, then complex conjugate, okay, and identity matrix. Just you see, you go through all these things that we have given here. It is made up of only with this, and even I'm telling you, a 10th class student can understand all this. You don't require BTech, MTech, PhD to understand these words as of now. So generally, that's why even a 10th class student who is comfortable with these topics, he also can start work. And if he is having some idea about programming, he also can start working with quantum computing. Computing is nothing but some programming we need to write, but to understand it, theoretically, we need to know about this terminology. So once if that is the case, we can start exploring that. Okay. Now qubit. Yeah. I think with this, yeah, ultimately, as I'm telling now, you see here, this is the thing. So your qubit is represented by using this notation psi alpha cat 0 plus beta cat 1. Okay, just you remember. But now, what is this one I told? What is cat 0? Okay, forget about even that 0. Some A I have written. What do you mean by cat A? It is a vector. Vector multiplied with some alpha. What is that alpha? some probability. Then what do you mean by probability? Is it a number or some character? What is the value of probability? 0 to 1. So you are multiplying one vector with some number which is in the range of 0 to 1 added with another, what is that, column vector with another number. So that whole together is known as one quantum bit. Ultimately, this entire thing you are getting the resultant column vector. See, psi is one column vector which is made with either cat 0 or cat 1. So that is what I am telling. No, it can be in the combination of 0 and 1. Okay, whereas in our what is that, classical, we write either 0 or 1, but here we need to write as a combination of 0 and 1 because this is for 1 qubit. If you say 2 qubits, we'll be writing all the combinations 0 0 0 1 1 0 1 1. If I say I'm using 3 qubits, you have to write alpha 1 triple 0, then alpha 2. Simple. So can you tell me what are all the possible combinations with the three bits? 0 0 0, then what is the next one? Triple 0 double 0 1, then 2 0 1 0, then 0 double 1, then 1 double 0, 1 0 1 1 1 0, and 6 ones. Then for that, do you really require any great knowledge? Nothing. So each component is multiplied with alpha 1, alpha 2, alpha 3 up to alpha 7. That whole combination is known as the quantum what is that, state of this given circuit or given outcome. Okay, yeah, with this I think I'll stop it here. If you have any doubts, you can ask me, but frankly speaking, I haven't discussed anything. Just I told what is quantum computer, how it is different from other computers. So in our computer we use bits. In quantum computer, if you want to work, you must work with quantum bits. Okay, and generally I discussed it is going to be very fast when compared to your classical computer, and there are different algorithms. And obviously, when I said it is algorithm, it is algorithm, whether it is classical algorithm or quantum algorithm, it is an algorithm. So we'll give some input, we are expecting some output. But the way in which it has to be designed is by using quantum bits. So based on that, we'll discuss something in the afternoon session. Okay, so if you have any doubts, you can ask now. Okay, I think all of you are feeling hungry, no? Please feel free to ask because that has come all the way to provide a lot of information. Our time, so we can please try to make use of this. No, feel free to interact. Nothing wrong in that. Even I also just started 1 year, and if you start now, I think maybe next year you will be in advance when compared to me, surely, because you will be getting a lot of time to look into this. Those who are doing at least studying, or those who are doing a PhD, you can spend a lot of time. But as a faculty, we are spending little bit of time only. But you get more, like majority of the time you can spend and you can learn a lot. And you need not depend on anyone to learn it. So anyhow, as you are having internet and so many facilities are available, you can go through them and you can learn. Yeah. How many? How many? No, no. Qubit itself is one bit. It can be there in multiple locations at the same time. Qubit means it is one bit, but it can exist in all the locations at the same time. No, no, because one qubit, it can be 0 or 1. If you use 2 qubits, so it can be there in 4 possible combinations at the same time. If you use 3 qubits, it can be there in 8 locations at the same time. 8 states. If you use 4 qubits, then for example, if I use 4 bits, what is the answer you can tell? You can tell either 0, 1, 2, 3, only one at a time. But when you use 4 qubits, I can tell it can be there in all 16 possible cases at the same time. It is to the power of that n value only. Okay, right. So anyhow, good. Because it is the first class, you note down all the words which are new to us, many of us, because the terminology, you go through the internet, get the concept clear, then we'll do it. But in the afternoon session, I'm telling you whether you know it or not, surely I'll be showing you some example. Surely we can complete the task. Still we'll saying that that is done in the quantum environment. Okay, right. Thank you. Yeah, okay.
One question from online participant, like, how does the quantum entanglement work?
Quantum.
How does the quantum entanglement works?
So that, frankly speaking, even I too don't have much idea about that. So only the programming part we started exploring it, but entanglement, that and all, no, physics people can tell that. Even I too don't know much about that.
Are quantum computers parallel computers?
Yeah. Because of that superposition only, that parallel mechanism comes into existence. The speed that we are achieving is all because of that superposition, which is considered as the parallel computing mechanism in quantum environment. Because that we should have the clarity. Right. Thank you. Yeah, announce చేస్తారా? ల్యాప్టాప్ ఒకసారి అయిపోయింది అక్కర్లేదు. ఆఫ్టర్నూన్ దానికి ఉంది, సరిపోయింది అక్కడ సరిపోయింది. హాయ్ సార్. ఓ నైస్ టు మీట్ యూ. మీకు యూ హ్యావ్ కోర్స్ నౌ ఇన్ క్వాంటమ్ కంప్యూటింగ్ హియర్? ఓ గుడ్. ఓకే. ఓ ఫస్ట్ టైం యు ఆర్ ఆఫరింగ్ హియర్ నౌ? ఓ somebody taught it. Very good. Who taught it? Oh, okay. Oh.
We are focusing on theoretical ideas.
Yes. Everyone was, but we started doing some programming. Yeah. Yeah.
So for online participants, kindly rejoin the session by 1:45 p.m. sharply.